Hello friends, in this video we are going to discuss the third numerical related to pulse width modulation technique. So let us read the example. A single phase full bridge voltage source inverter controls the power in a resistive load. The nominal value of the source voltage is 220 volt. Okay, so it is given source voltage, that is a EDC, is equal to 220 volt. Next, and a uniform pulse width modulation with 5 pulses per half cycle. Okay, so it is a multiple PWM, right? Multiple PWM technique is used. PWM. Okay, next, number of pulses per half cycle, that is a P, is equal to 5. For required control, the width of each pulse is 30 degree. Okay, so delta is equal to given, it is a 30 degree. First, determine the RMS voltage of the load. Okay, so in the first bit we need to find the RMS voltage of the load. Okay, so we can write V0 RMS is equal to, yes, we are having expression, it is under root P delta by pi, under root P into delta divided by pi. Okay, under root P delta by pi into EDC. Okay, so we can write it is equal to under root, yes, what is the P? P is a 5 into delta. Delta is a 30 degree. Okay, so in radian it is a pi by 6 divided by pi. Okay, into EDC it is a 220. Okay, so it is a pi will get cancelled. Yes, it is a under root 5 by 6 into 220, right? So root 5 by 6 into 220. Okay, it is a 200.83 volt. This is V0 RMS will be heavy. Okay, so answer for the first bit. Okay, very straightforward, simply put the formula. Okay, next, second bit. In the second bit, if you check, they have asked if the DC supply voltage increased by 10%, determine the pulse width to maintain the same load power. Okay, so we need to maintain the load power which is the same as that of this term. Okay, same as that of this value. Okay, next, our task is to find pulse width. Okay, pulse width to maintain the same load power. Okay, so pulse width means delta we need to find for the second bit. Okay, and it is given that supply voltage is increased by 10%. So now EDC is equal to 10% increased, so it is a 1.1 into what is the EDC given? EDC given is a 220, so it is a into 220. Are you getting the point? Because EDC is increased by 10%, so it is a 220 into 1.1, so it is a 242 volt. Now EDC is 242 volt. Okay, now in order to keep the same load power, so therefore load power, that is a P0, is equal to what? V0 RMS square divided by R. Okay, what is the V0 RMS square? It is a 200.83. We need to keep the load power same as that of the first bit, right? So it is a 200.83 divided by R, 200.83 square divided by R. Okay, so whether R value they have given? No, right? And it is not required also. So it is a 200.83 square. So it is a 40332.6. 40332.69. Okay, divided by R. Okay, this is the P0 actually. This is a P0. Okay, now our task is to find the delta. Task is to find the delta. Now, in order to get this P0, right? So, what is the required V0 RMS? Yes, for getting this P0, the required V0 RMS, it will be same as that of this case. Okay, then and only then it is possible. Okay, so as P0 is constant, is kept unchanged, right? Therefore V0 RMS will remain same, okay, so now V0 RMS is to be same, means what? V0 RMS which is same as that of the previous case. Okay, so we can write it as a V0 RMS should be same, means therefore we can write V0 RMS is equal to what? Under root P delta by pi, P into delta divided by pi into EDC, Okay, what is V0 RMS? It is a 200.83, 200.83 is equal to what? 200.83, right, is equal to under root P is 5 into delta we need to find divided by pi into EDC. EDC is new EDC, right? It is a 242. Okay, so therefore from this can we find delta? Yes, delta is equal to, we can find. So therefore it is 200.83 divided by 242, right? Answer square into pi divided by 5. It is a 0.4327, 0.4327, right? It is in radian, right? So in degree it is into 180 by 5. 24.79, 24.79 degree. Okay, this is the required value of delta, right? Required value of delta. Is this clear? Okay, so because as supply voltage we have increased by 10%, so therefore delta required will be reduced. Okay, so 24.79, this is the answer for the second bit. Okay, next let us read the third bit. If the maximum possible pulse width is 35 degree, now delta is 35 degree, determine the minimum allowable limit of DC input source voltage to maintain the same load power. Okay, again the load power to be same means what? V0 RMS to be same. Okay, so third bit, for the third bit we can write, yes, delta is equal to 35 degree, delta is equal to 35 degree. Okay, so now if delta is 35 degree, in order to maintain the same load power, okay, so load power is same and our task is to find the EDC. Okay, so as P0 is the same, therefore V0 RMS should be same. Okay, should be same. So therefore we know V0 RMS is equal to V0 RMS is equal to, yes, it is 200.83, right? 200.83, 200.83. Okay, so further we can write V0 RMS is equal to under root P delta by pi into EDC, right? Under root P into delta by pi into EDC. Okay, so what is the V0 RMS? It is a 200.83. 200.83 is equal to what? Under root P, right? They have asked the limit of the DC input. Oh, yes, means P will remain same, that is a 5 into delta is 35 degrees, so it is a 35 into pi by 180. We need to convert that degree to its radian equivalent divided by pi. That is pi will get cancelled. Okay, into EDC we need to find new EDC, right? So therefore from this we can find EDC is equal to, yes, it is under root pi into 35 divided by 180. Okay, so it is a 200.83 divided by answer. Okay, so it is a 203.67, 203.67. This is the required EDC, right? Required EDC in order to get the same load power, in order to get the same load power. Is this clear? Okay, so this is about the numerical related to the pulse width modulation technique.